luck in the math today. Checkpoints. Drink me. No, I drink you. I'm your father, Darth Vader. I'm the only one who could drink out of your cup. Sorry, students. Hey, guys, checkpoint 1. Let's rock it. A couple of things I want to show you today that might be a little bit helpful in your notes. Do you know the values of these powers of 10? 10 to the power of 1, 10 to the power of 2, 10 to the power of 3. Multiply 10 times 10 times 10. You get 1,000. 10 to the power of 4. 10 to the power of 5. When you see 10 to the power of 5, think 100,000. Write that down in your notebook for quick reference if you don't have it. Now, something a little new today. What is 10 to the negative 1 power? 10 to the negative 1 power is 1/10. 10 to the negative 2 power is 100. 1,000. 10,000. 100,000. I'm going to show you the what. I'm not going to show you the why today. Get it all in reference. It's going to help you right now. All right, we've been on this checkpoint for some time. Get it out. If you don't have it out, it is the what is the result of 378 times 100. Compare that to the result of 378 times 100. I have two new problems here. I don't want to do the actual math for you, so let's do these example problems together. And hopefully then you'll see how you can, on your own, do the other problems. What is 6,042 times 100? Let's get it into this place value chart first and see what happens. If I multiply this number 100 times, I'm going to make a number that's 100 times bigger. Let me say that again. If I multiply a number by 100, I'm going to make another number 100 times bigger. There are 2 zeros in this product, and everything else, every other digit stays the same. Let's check out and see what happens in our place value chart. The 2 becomes a 200. A 4 becomes a 410. 10,000s, 100,000s. There are no 10s and no 1s. I just made this number 100 times bigger. Why? I times it by 100. What happened? The decimal point, which was here, is now here. It's now after 2 zeros. I've told you a trick before, and I haven't done a great job with explaining why it's so. Where's the decimal point with 6,042? It's right after the ones place. When I multiply it by 100, I can move that decimal point 2 places, and now I have 2 zeros, 2 more zeros before the decimal point. That number is now 604,200. I made it 100 times bigger. Yes, you can think about the decimal point moving, but a better way to think about it is the place values change. The digit is the same. This 10 got 100 times bigger. Now it's 4,000. This 2 got 100 times bigger. Now it's 200. What happens if I multiply that number by 100? I am making it 1/100th of itself. I'm not multiplying it by 100. So this number that is 6,042. Instead of making it 100 times bigger, moving this decimal point or moving the digits 2 place values to the left, I'm now going to move those digits 2 place values to the right. 6,000 divided by 10 is 600. 4 tens, 40, divided by 10 is 4. 2 divided by 10 is 2 tenths. But I'm not making it 1 tenth smaller, I'm making it 100th smaller. So instead of 1 place value moved over, I'm going to move it 2 place values over. 6,000 divided by 100 is 60. 4 tens divided by 100 is 2 ones divided by 100 is 6,042. What's 100th of that? 60 and 42 hundredths. There's another way you can think about this. What is 100th? Well, we haven't been working with fractions much, so I can rewrite that as 100th. 100th is the same thing as 10 to the negative 1 power. Excuse me. Thank you for that. I knew your thinking that was wrong. That's 100th, not 1/10. 100th. The problem is, what's this number times 100? Negative 2, 10 to the negative 2 power is the same thing. What happens when I multiply something by a power of 10? I can think about moving the decimal point. You can now start to think about moving the digits within a place value chart. What happens? Well, the same thing happens that you saw here. The decimal point was here, and it moves 1, 2 place values to the left. 60 and 42 hundredths is 100th of 6,042. If I multiply this number by 100, I would get 6,042. If I had 100 of these, I would get 6,042. Now let's do that check real quick. Let's multiply it by 100 and see what if we get back to where we started. When I multiply a number by 100, I can think about moving that decimal point. How many times are we moving it? We're moving it twice, or we can think about moving place values twice. 1, 2 times. That number, indeed, if I multiplied it by 100, is 6,042. That is 100th of that number. How do these two numbers compare? How does the number 6,000, how does this number compare to this number? Let me write it out. Think about it. How much bigger is this number than this number? Let me write it one more way that might help. 60 and 42 hundredths, if I multiplied it by a number, what would get me to this first answer? It's a power of 10. You can think about a power of 10. You can play around with those numbers that you see down here. When it says, how does the result compare? You can say 60 and 42 hundredths is blank times smaller than 604,200. Or if you wanted to write about how much bigger that number was, 604,200 is blank times okay, all this should help you out with number 2. You'll need to compare it with the results above. So again, this was the answer to my first problem. This was the answer to my second problem. How do I divide 6,042 by the power of 10? What does the power of 10 mean? It means 100. So I can rewrite this problem as that's more comfortable for me. Instead of having these numbers in the chart, let's rewrite it one more time. 6,042. If I divide this number by 100, what happens? If I divide 6,000 by 100, and in your mind you can think about this, 6,000 divided by 100, what is that? That's 60, 6/10. I'm moving it 2 place values to the right. What's 4 tens or 40 divided by 100? You can think 40 hundredths, because a division problem is a fraction. And if I move it over 40 hundredths, that's 4 tens, which is equal to 40 hundredths. And then finally, 2 divided by 100, that's 2 hundredths. You can think about that as we watch 2 ones move over 2 place values. Why am I moving it over 2 place values? This relationship is important in this place value chart. When I move to the right, to the left, that's 10 times bigger, every place value. Every place value going to the right is 10 times smaller, or 1/10 smaller. Or you divide it by 10 every time. 2 jumps, 100. 2 jumps, 100. 6,042 divided by 100 is 60 and 42 hundredths. I've also shown you this method, the moving decimal method, which doesn't talk to you about the why, but it's important to get down the what. If I divide a number by 100, how many times am I moving that decimal point? Once, twice. And we still get that same answer of 60 and 42 hundredths. How does that number compare to the results above? Hopefully what I wrote out here helps. This is the same value. How much smaller is it compared to this number? And notice how this question is just like this question. I hope that helped. I hope that helped, please. I hope that helped. Look at the work. I hope that helped. Small group if it didn't, because you're awesome and you will eventually get it.